Hello students, in today's class we are going to talk about Antimarkonikoff's role. Actually, this is peroxide effect. Why this is called so? In presence of peroxide like benzoyl peroxide, C6H5, C double bond O, 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 C double bond O, C6H5. In presence of the following type of peroxide, the reaction takes place. It is mainly following free radical addition. So how free radical is generated here from the benzoyl peroxide? Or that can be understood as follows. Just see C6H5, C double bond O, 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 C double bond O, C6H5. This compound is benzoyl peroxide. In the stage 1, there is a chance of homolytic cleavage. So this is what is happening. The bond is breaking up into homolytic phase. As a result of that, we can have two free radicals like this. Okay. The free radical is obtained as follows. From this free radical, in the next step, just see C6H5, C double bond O, O free radical. Again, here the homolytic fission takes place as follows. This bond is homolytically cleaved. So the ring is getting one electron and other electron is used by this carbon atom for the bond formation. It indicates that there will be double bond in between the carbon and oxygen. Due to that, you can have C6H5 radical plus carbon dioxide gas. So the smeared C6H5 radical, when it is in contact with the hydrogen bromide, it is homolytically cleaved like this, and a bond is formed, and it is taking up its electron. So that results to the formation of benzene and bromine free radical is formed. So this free radical should be added to the asymmetric alkene, and with the help of peroxide it is being generated, and hence it is called as peroxide effect. So how to continue with the action? The action can be continued as follows. Yes, we can take the most suitable example, CH3, CH double bond CH2. The compound is said to be the propene. When the propene is in contact with this radical, Br radical, what happens? There are two chances. These are the two possibilities. Now, the pi bond is broken homolytically, okay, and thus merged free radical is going to combine with this Br. So this is one of the chance. You can have CH3, CH, it becomes CH2Br. Now this is carrying the electron. So this is what kind of intermediate? Secondary free radical. Carbon free radical is as an intermediate. Instead of that, one more possibility, this is the other chance. When the bond is formed, you just consider this is the pi bond, it is homolytically cleaved, and there will be attachment in between these two. So this carbon is involved in the bonding means you can have CH3, CH, Br, and CH2. This is carrying the electron. This is said to be the primary free radical, carbon free radical is made. And we know very well about the stability of primary and secondary. Secondary is more stable than the primary. So the addition should follow this mechanism rather than this. So we should have the first mechanism in which secondary free radical is made as an intermediate. So when you continue in the next stage, and we will be treating this with HBr once again. Here I can write that HBr. Now the hydrogen is going to share its electron. As a result of that, we will be having CH3, CH2, and CH2Br. And here, when you supply the hydrogen bromide, what is happening? The bond is formed in between these two, and this is being leaved. And you can have CH3, CH, Br, and CH3. This is said to be the 1-bromopropane, and this is called as 2-bromopropane. So among these two, this would be the major product, and this is said to be the minor product. This is the way by which you can understand the peroxide effect, Antimarkonikoff rule. So the Antimarkonikoff rule is following the free radical addition that can be summarized as follows. When the addition of HBr to alkenes, in particular asymmetric alkenes, in presence of peroxide, the following things are possible. These are the possibilities. Hydrogen radical goes to the carbon having more number of alkyl groups, or we can say lesser number of hydrogen atoms. In contrast, if you consider the Br radical, bromo radical, that goes to the carbon having lesser number of alkyl groups, or more number of hydrogen atoms. So in this manner only the addition takes place, and hence it is called as free radical addition. The free radical addition of hydrogen halide to the asymmetric alkene is thus explained. And normally we will be having some doubt. HBr undergoes this. What about HCl and HI? Normally in the HCl, the bond energy is roughly about 430.5 kilojoules per mole. But if you take HBr, it has got 363.7 kilojoules per mole. So it's a comparatively weaker bond, the HBr. So it undergoes homolytic cleavage more readily to generate radical. But here the HCl do not undergo homolytic fission. Homolytic fission is not easier in the case of HCl as it is having greater bond energy. But the hydrogen iodide, it has got the lowest energy, 268 point or approximately 296.8 kilojoule. It can readily form free radical, but the iodine free radicals are combining with each other to form iodine molecule. That's the reason why always the HBr is selected in the case of peroxide effect. So that's the explanation about the peroxide effect.